So last day before break, we're going to talk about Le Chatelier and Le Chatelier's principle. This will be the last stuff that we need to learn before the test, so that'll give us some time to do some review and do some, hopefully, revamping and get to know what we need to know. When we come back from break, we'll do, the first day back, we'll do a little bit of a review. We'll do 2 little small mini labs, and then check off your labs, for your pre-labs for the actual experiment number 11 that you need to be doing the next time. And then the time after that, we'll finish up 11 and do a review and then the test. So we only have 3 days once we get back. So it's sort of 4 days. 4 days. Yeah, 4 days. Okay, and then that's the end of the term. So we're going to talk about Le Chatelier. The silver test tube that we're doing is actually, if you go on to 1120, because you can't take it here, you have to take it up at the college. It's part of the organic biochem test that they do that shows aldehydes versus different things. Anyway, it's a test that they use, and it was also used to make mirrors, the old-fashioned mirrors. So if you see those, that you're going to make a mirror inside the test tube, and you'll get to take it home. Okay, so factors that influence Le Chatelier. So once we have equilibrium, that's where we ended last time, was equilibrium. We can affect that equilibrium by putting pressure on the system, basically is what Le Chatelier says. So the pressure can be influenced by changes in concentration, change in temperature, change in pressure, anything that there's a stress. So it's sort of like a teeter-totter. If somebody is doing a teeter-totter, they're equally balanced, they can go up and down by pushing with their legs, but then if somebody else gets on one side, then the equilibrium is not quite balanced, so you need somebody else on the other side, kind of thing. That's why the teeter-totter. So you try and relieve the stress. So either I can move the fulcrum of the teeter-totter towards the heavier person, or is it the lighter person? Yeah, towards the heavier person, then it equals out. Or I can add more people on the side of the lighter person. Okay? So basically, Le Chatelier will undergo to relieve the stress. So you just got to remember that. Okay, so, yep. Okay, we okay to go forward? All right. So if a chemical system is stressed, I talked about this on the last one. Some of the possible disturbances are concentration, temperature change, or pressure. And we're going to talk about each one of these. So you'll want to make sure that you know what things can change and what will cause disturbances. Concentration, temperature, or pressure changes. Those are the things that we can change, and it makes it shift. Okay, concentration, temperature, and pressure. So for concentration change, if a concentration is increased, I always start, if a concentration is increased, I put the arrow on the top like it's right here. Okay, and then it will shift away from where I'm putting things on top. So it has to cross the equilibrium arrow, so that tells me which way it's going. Okay, so if I put it in on this side, then it's going to shift to this side. If I put it in on this side, it'll shift to the other side. It has to cross the arrow. So if you remember that, then what happens is if I'm putting more CO here, it's going to drive the reaction to the right. In doing so, I will get less oxygen and more CO2 at equilibrium. Okay? Now, if I add more product, it's going to shift away from the product and make more reactants. So it drives the reactions to the left or towards the reactants. I'll end up with more oxygen and more CO2. Okay? Sort of get the idea here. Okay? If concentration changes by removing a product, then you have to cross the arrow and follow that arrow down. And I put it underneath. So I'm removing it, it goes underneath, and I have to cross and follow the arrow down. So I have to cross the arrow. So I'm trying to fill that hole. So I'm making a hole and I'm trying to fill that hole. So as I'm doing that, as I'm removing that, I'm actually making more ethene, which is what this is, and losing ethanol. Okay? If I increase the temperature, now remember, temperature can go inside, and since this is a positive here, it actually is like it's added on this side. So if I'm adding temperature, that means I'm going to be adding it on this side, and it's going to shift that way. Okay, if it was a negative, then I would put it like it was over here, and I would act it the same way. Okay, this is an endothermic process. If it's endothermic process and I add heat, it's going to shift towards the products. So if it's an exothermic equation, then it's basically like adding the kilojoules here, and I would be putting in energy here, and it would shift away from it. Okay? Now pressure. Pressure is a little bit different. You have to know what are gases. The gases and how many moles of each you have. So here I have 1 plus 3 gives me 4 total moles, and here I just have 2 moles. So as if I increase pressure, we'll go to the side that has the least amount of moles of gas. If I decrease the pressure, we'll go to the side that has the most. Okay, so you just sort of have to watch that. More moles, more pressure, towards the fewer moles. So if I decrease the pressure, we'll go reverse. The side that has the least are the more moles. The least side will go to the more. Okay, so now we're going to take a generic equation. Here's a generic equation, and we're going to pretend what we're doing here. So if I'm adding reactants, I'm going to do the blue. It's like I'm adding on this side. Okay? So because I'm adding reactants, remember I've got to cross this arrow in the center, so it's like I'm going that way, right? So I would be increasing the number of products. So it would shift toward products. Okay, if I remove reactants, take them out, remember the arrow has to be continuous across this line, so it's like it's going like that. So it would shift towards the reactants. Adding products, putting it in on this side, remember it still has to cross that arrow, so it will shift towards the reactants. On the last one, removing products, arrow out here, I do still have to cross that arrow, so it would be coming this way. So it would be shifting toward the products. Okay, I got a lot of arrows on there. Everybody okay? Does everybody understand that? See how I'm doing it? If you do the adding on top with the arrows, it'll push you away from it, so you'll know where to go. If you put the arrows on the bottom, you know you have to cross the main arrow to get to them. So that'll always help you go what direction you need to. All right, so here we have one that's an actual equation. It has heat in it. It has gases in it. I need to worry about what's going on each of that. So temperature increase here, that means I'm adding kilojoules. Now, it could be written in the equation like this, or it could have been written as a delta H as a negative 45.8 degree kilojoules. Remember, negative just means it's on the product side. Okay? So if I increase the temperature, which way am I going? Towards the reactants or towards the products? I'm just going to do the arrows up or down here, not across for you now. You've got to do one more thing. So which way am I going? Point with your finger. I've got some of you going, is it going towards the products or towards the reactants? Reactants. You should be heading towards the reactants. I'm going to shortcut a little bit here. Okay, the next one, temperature decreases. So I'm pulling this out now. Point with your fingers. Tell me which way you're going. I want to see that everybody knows. All right, yes, you're going towards the products. Okay, increase pressure, decrease volume. So now what do I need to do? What was the special thing about pressure? We need to be working about the moles of gas. So I've got 1 plus 3. Let's go. I did a plus twice there. That'll give me 4 moles on this side. I've got 1 plus 1. I've got 2 moles on this side. So increased pressure, decreased volume. So I'm taking that balloon and I'm squeezing it down. What's going to happen? Show me which direction you think it's going to go. Increased pressure, decreased volume. It'll go to the side that has the least number of moles. So it'll go towards the products. Okay, the next one. Decrease the pressure, increase the volume. So they could use either one of these wordings. They could say increase the pressure or they could say decrease the volume. Means the same thing. So you got to get it in your head. So decrease the pressure or increase the volume. Which way is it going to go? Products or reactants? Reactants. Good. All right, let's go forward here. So we're just doing a whole bunch of different ways that they could possibly say this. So which way will the equilibrium shift if CO is added? So if I go up here, CO is added. Which way is it shifting? Towards the product. I'm now just going to shortcut with an arrow and a P. Okay. H2 is removed. So where's H2? It's right here and it's removed. Reactants or products? Good. It'll shift towards the reactants. I'm shortcutting it, but you'd be looking for something that says shift towards the reactants. Okay, H2O is added. H2O is on the product side, and I'm adding it. Which way? It's towards the reactants. Good. So it'll shift. If I'm adding it, it shifts away from it. If I'm taking it out, it shifts towards it. Okay, our CH4, or methane, is removed. Where's methane? There it is. Methane is removed. Products or reactants? Ooh, I heard reactants. So if I'm taking it out, it will shift towards it. So I'll try and fill that hole. So it will shift towards the products. If I'm putting it in, it's like, have you ever had my dad used to have either manure or topsoil delivered every year. And they would dump it in a pile in front of our yard. And we would then have to spread it out, right? So I think of it that way. So if they dump something in my front yard, they add something, then I've got to spread it out. I've got to push it away. If they dig a hole, my dad, like the dog, would always dig the holes during the dog, would have to go and fill them up, right? So that's what you're thinking of. If I make a pile, I've got to spread it out. If I dig a hole, I've got to fill it up. So shift towards. Okay, so volume is decreasing. Therefore, pressure is increasing. What do I need to look at for that? Moles. And it only can be moles of gas. That's very important. Can't be aqueous, can't be liquid, can't be solid, only gas. So I have gas here and gas here with a 3 and a 1, so 4 on this side. Gas here, 1 in front of each of those, so there's 2 on this side. Which way is it shifting? Towards the products, right? Towards the least amount of moles of gas. Okay, heat is added. Again, this could be off to the side as a negative 45.8, right? So which way is it shifting now? Yeah, it's shifting backwards towards the reactants. Okay, thumbs up, I'm getting this. Thumbs down, I'm not. Thumbs sideways, still shaky. Okay, let's keep going. So we talked about activation curves last time. A catalyst just lowers that activation curve. Okay, it doesn't have to be a nice straight curve like it's showing right here. It could actually go like this, something like this, and still end up like that. Okay, a catalyst just lowers the overall energy that I need to get the reaction going. And because of that, it speeds up the reaction, because whatever energy I've got can be used to go through that reaction a lot more. Okay, instead of just hitting that curve and going over. Who remembers what this total distance is called? Everybody looks back. This is the activation energy, right? What if I went from here all the way to the top. What was that called? Yeah, activation energy of the reverse reaction, or activation energy prime. What was the difference between where I start right here and where I end right here? What was that distance right here? Okay, where I started was potential energy of the reactants. Where I ended was potential energy of the products. Now what's the difference? The change, the delta. So this is delta E if it's energy. If it's heat energy, it's delta H. Okay, depending on what you're using. So you got to look at the side. Remember that they will give you a chart sort of like this, and you're going to have to be able to read it and give them actual numbers. Okay, so that was just, and you might say with the catalyst or without the catalyst, and what's the difference, kind of thing. Okay, so back over words, catalyst is like what? What did I compare it to? And what did the video compare it to? Fiddler on the Roof? Matchmaker. So it's a matchmaker, okay? So a catalyst is like a matchmaker. What does it do? It lowers the activation energy. Okay? Energy of activation is what? The amount of energy it takes to get a reaction going. Okay? Or the amount of energy it takes to get up the courage to go ask somebody for a date or to the dance. Okay? Net energy of the reaction, that's your delta E or delta H. The potential is where did I start and where did I end? How much energy they had. Okay? Be able to label any of it. Be able to tell if they have these things labeled like A, B, C, D, E. Be able to tell them what each one is. Okay? Going forward. And that's what we're ending up with today. So we have now got everything for this unit, this chapter. Everything is in there. We're going to go over a little bit more next time, but we've covered everything. Okay? So you need to make sure that when you come back, you've got your homeworks basically done. If you have questions, that's great. Bring it back mostly done with a couple questions. We do it that first day. You need to have your Learn Smarts done when you come back from break. So if you're not there, you have break to get it done, but you need to get it done before you come back. Okay? So when we come back, that we can focus in on that lab, because that lab's going to be a little bit of a bugger to get done. Okay? And we got to have it done by the end of the term. And I want to make sure we focus in on that review day on, I want to do a speed dating, speed probleming, where you switch partners, and go through what would be on the whole test, and then ask questions. So that's what my plan is, to try and help you do a little bit better on this next test. We're going to now spend the time, the computers are open. I am going to take Green back with me first. So if Green will put goggles and aprons are your choice, but that we are working with some pretty caustics. And meet me at the front of this little thing right here, and we'll go through what you need to. You don't have to take anything back with you, so leave everything here. It's very important that you don't take anything back with you. When they get done, or when they are through the line, Red, I'll be asking you to come back, but until that point, please grab a computer or work on your lab, whatever you need to get done today. Homeworks, Learn Smarts, labs. Okay, and that first day we come back, I'll be checking lab before you'll be able to go in lab the next time. Okay? Questions? All right, let's break. Let's go.